am Meghna Parikh, and today we are here to start a lecture series of Mathematics-02. Our chapter is Laplace transform, and today our topic is partial fraction case 1. In last session, we are discussed about the inverse Laplace transform, first shift theorem, second shift theorem. Okay, so when we have a root type of the formula or partial fraction formation of the equations, then we are applying partial fraction for the equation, find the value of ABC and apply inverse Laplace transform for the individuality. Okay, so we start. First of all, method of partial fraction. When factors are linear and distinct, we say 1 upon s minus a, s minus b, then we are taking a upon s minus a plus b upon s minus b. This is our case 1. What is case 2? Case 2 say there is a linear root are repeated. So s minus a raised to n. So we create a polynomial in denominator, s minus a plus s minus a whole square plus s minus a whole cube. So both are linear formation. Case 3, when factors are quadratic and distinct. That means 1 upon s square plus as plus b and s square plus cs plus d. Both are quadratic roots or complex roots. Then we are assume as plus b upon s square plus as plus b plus cs plus d upon cs s square plus cs plus d, individual factors. Now, if quadratic factors are repeated, then we are using 1 upon s square plus as plus b whole square equal to as plus b upon s square plus as plus b plus cs plus d s square plus as plus b whole square. We are create again a polynomial form in denominator. Okay. So in this lecture, we will discuss about the case 1 examples. So for the example, first is find inverse Laplace transform of 1 upon s plus under root 2 s minus under root 3. Okay. Solution. First of all, Laplace inverse 1 upon s plus under root 2 s minus under root 3. Okay. We are taking 1 upon s plus under root 2 and s minus under root 3 equal to a upon s plus under root 2 and b upon under s minus under root 3. So 1 equal to a s minus under root 3 plus b s plus under root 2. Equation. This is our equation 1. This is our equation number 2. Okay. Now, we are taking s equal to plus under root 3 because here we have the factor as a s minus 3. So, we are taking a positive value of that. So, taking s equal to under root 3 in equation 2, we get 1, 0, b under root 3 plus under root 2. So what is the value of b? Value of b is 1 upon under root 3 plus under root 2. Similarly, s equal to under root 2 in equation 2. 1 equal to a under root 2 minus under root 3 plus 0. So a equal to 1 upon under root 2 minus under root 3. We are getting a value of a and b. Put this value in equation 1. What is our equation 1? Equation 1 say that 1 upon s plus under root 2 s minus under root 3 a upon s plus under root 2 b upon s minus under root 3. Now what is the value of a? We are applying Laplace inverse. Value of a is under root 2 minus under root 3 upon s plus under root 2. Sorry. What is the value of A? A is 1 upon under root 2 minus under root 3. Laplace inverse of 1 upon s plus under root 2. Plus, what is the value of B? B is a 1 upon under root 3 plus under root 2. Laplace inverse of 1 upon s minus under root 3. So, answer is 1 upon under root 2 minus under root 3. What is the Laplace inverse of s plus under root 2? It is e raised to minus under root 2t plus 1 upon under root 3 plus under root 2 e raised to plus under root 3t is the answer of the example. Okay, so this is a case 1 example, the partial fraction. We are taking individual factors, find the value of ABC, put the value of ABC in equation. After that, applying Laplace inverse both sides and using a inverse Laplace formula, we getting an answer as a T form. Okay, so it's your last answer. Next example. Find inverse Laplace transform of 3s square minus 1, s plus 1, s plus 2, s minus 3. So, first of all, Laplace inverse 3s square minus 1, s plus 1, s plus 2, s minus 3. Okay, so we taking a upon s plus 1, b upon s plus 2 and c upon s minus 3. This is our equation A. Now, taking LCM, 3s square minus 1, a s plus 2, s minus 3, b s plus 1, s minus 3 and c s plus 1, s plus 2. Okay. Now put this equation 1. Put s equal to minus 1 in equation 1. Minus 1, 3 minus 1, a minus 1 plus 2 minus 1 minus 3. Remaining value are 0. So it is 2, a 1 and it is minus 4. So we get a equal to minus 1 by 2. Now we are taking s equal to minus 2. So 3 minus 2 whole square, 4 minus 1, a is 0, b minus 2 plus 1 minus 2 minus 3 plus c 0. So 3 4s are 12, 12 minus 1, 11, b minus 1 minus 5. So b equal to 11 by 5. Now s equal to plus 3 in equation 1. So it is 9, 3 is 27 minus 1 it is 26. A 0, B 0, value of C 3 plus 1 and 3 plus 2. 4 and 5, 20. So C equal to 26 by 20. We say that it is 13 into 2 and 10 into 2. So it is 13 by 10. Value of C is 13 by 10. Now we are putting value of ABC in equation 1. So Laplace inverse of 3s square minus 1, s plus 1, s plus 2, value of a is minus 1 by 2, Laplace inverse 1 upon s plus 1. Value of b is plus 11 by 5, Laplace inverse 1 upon s plus 2, plus 13 by 10, Laplace inverse 1 upon s minus 3. So answer is minus 1 by 2 e raised to minus t plus 11 by 5 e raised to minus 2t plus 13 by 10 e raised to 3t. This is your last answer of the example. Okay, clear? So here we are completed case 1 of the partial fraction. Okay, thank you. Thank you.